Multiplying polynomials. I did grab a couple of the error analysis problems, different than the ones that are actually assigned for today. But just because I had a call out from a couple students this morning that they didn't quite understand what they were asking. Like when it says which line is the error in, they called out, and it makes total sense when they said it. But after one mistake happens, every line below it is wrong too. So you're picking the row or the line that the first mistake happened on your Google Doc today. Or it's not Google Doc, Google form. So it's the first line that you find the first error is the one you're paying attention to. And then obviously you're going to discuss what they did wrong, how to fix it, and then give the right answer. Be really careful as far as typing in as well that you use the right letters, and it gives you instructions for every problem to remind you. So again, huge call out, make sure you're reading the instructions because someone already inputted one wrong, which I can go back and fix. But if we're being realistic, it's a skill we want to work on between now and EOCs and end of finals or unit tests, because if it says in the instructions, especially in a virtual format, it's not as easy to pick up a piece of paper and go look at it again and regrade it or go find the things. So make sure you're reading really closely and answering the way it asks you to. All right, so this error analysis problem here, so it says there's an error. Another call out, if I give you an error analysis, there is going to be an error. If you can't find it, my suggestion is to take the problem itself, like the first, so in this case, just your first line, write it on another piece of paper. Do not look at this at all, and then rework it and then compare your work to their work. Because sometimes looking at someone's work, you can convince yourself it's right when it's just a silly little something, a positive or a negative that's off. And it's easy to overlook, especially if you have a lot going on in your mind. So in this one, for subtraction, you want to turn this into a positive because then that means I can just combine like terms. But then everything to the right symbol is going to switch, like everything. So since this was minus, or you can think about it as a -1 and distribute it through, whichever way makes more sense to your brain. So in this negative is going to make this a positive, and this a negative. So it'll be a -5. They did translate to a -5. They did translate to a plus 12x, which is great. They made their boo-boo right here. So here's your mistake. So in this case, maybe you would say line 2 was the first mistake. And then to fix it, obviously we know that's a positive 9x squared. So that 13, so negative 13x squared, its like term is going to be the 9, and that's going to be a positive 9x squared. And we combine those. If you're in the whole 13 and add 9 to it, you're going to still be in the whole 4. So negative 4x squared is going to be the combination of those two. So negative 4x squared, because that's our highest exponent, is going to go in the front to keep it in standard form. So it's going to go all the way descending order for your exponents. So 2. And then the next one would be x to the 1 power, or just x. So 12x is by itself. There's not another one in the line, so we're just going to bring it down. So plus 12x. And then we have a positive 5 constant and a negative 5 constant. So they cancel each other out. So we're done. That's your right answer. And the only mistake was in not switching the sign of that 9x squared and making it positive. There was a call out in last class discussing how to maintain the positives and negatives and keeping a hold of those. My call out would be 1. As you see, I'm using a red pen. Huge difference. In my class, in a classroom, there's highlighters and markers and red pens and things everywhere because I think it makes a big difference because I have squirrel brain myself and it keeps me focused on what I'm doing. The other call out is if combining like terms, especially when they get big, there's a lot of them. So I would use a highlighter, and I know this is, before I did my final answer, this is my x squared, this is my x squared, which hopefully you did in a Math 1 class along the way somewhere. If not, your 8th grade math teacher did it for you, where you color code your like terms, which sounds ridiculous, but let's be fair that at this point, Math 2 and up, you're going to get to some really hard math because it's high school math, and that's what math does. It gets hard. So on problems where it's really just combining like terms and you're using skills that you've had since like 8th grade and before, you don't want to make mistakes. So if it takes an extra 2 seconds to use a colored pen or a highlighter and you know you got it right, that's one question you know you're taking to your quiz, test, and you know you're going to get those points. So take the time. So slow down to make sure you're getting it organized correctly, because that's been the biggest mistake I've found students with adding and subtracting and sometimes even multiplying polynomials. is writing messy and just keeping it organized on your paper. So like not writing sideways or crazy stuff, which, I mean, if that's how your brain works, I understand. But I'm just giving you the call out to where I see most mistakes is just a matter of not writing neat enough and not staying in the game long enough, and then kind of checking out and then coming back and grabbing an answer. So one more error analysis for adding and subtracting. This is where you're going to combine your multiplication of polynomials and adding and subtracting. And it's fair game because, again, we're in math 2. So we're done with math 1 and we're done with 8th grade math. And this is all the same content. They just have to shake it up a little bit more and make it a little more advanced. So we're going to take that 5 and we're going to distribute it through. Most of you don't have a problem with distributive property. I'm writing those errors because those keep me grounded and paying attention to my problem. So 5 times a negative 3d squared is going to give me a negative 15d squared. And then 5 times a negative 2 is a positive times a negative, which is going to give me a negative 10. So you can keep going at this point, or you can look down, and we see we have a negative 15d squared. We're good there. And then they made a mistake at that plus 10, because that should be a negative 10 because that 2 was negative. After that, I would just check to make sure, because again, sometimes you've done it too. All of us have been there where we just slaughter a math problem and do lots of crazy things. But this one got translated down perfectly. Same, so you're good there. You did not have to change anything in the back because this was a plus. So we're just at that point combining like terms. The only work that needed to be done was distributing the 5 so we could combine those like terms. From there, you're going to, again, look at your like terms and combine them. So I'm going to take my negative 15d squared with my negative d squared, because those are the same like terms. I have a negative 10, which goes with my positive 7 because they're both constants. And then my negative 6d, which is by itself because there's not another d. And then again, we want them in descending order, standard form, always in descending order. So negative 15d squared and a negative d squared. So we'll give you negative 16d squared. Then you want to do your d by itself, so d to the 1 power. So minus 6d. Sorry for the handwriting, guys. And then at the very end, minus 10 plus 7 is going to give you a minus 3. Because if you owe me 10 and you pay me 7, you still owe me 3. I always like to think of minuses and negatives as owing money, because I don't mess up as much when I'm discussing money. So then this would be your final answer. And your error would have happened in the second line. And they didn't distribute the 5 to the negative 2 would be the error that this person did. All right. Do either one of you have any questions at the moment?
No.
Okay, perfect. Thank you. All right, so back to the slides. So multiplying, as far as multiplying our polynomials, you have 3 choices. And again, this is going to be repetitive to the video you're going to watch today anyway. So if this makes sense and you haven't already watched the videos, you might be able to get away with not watching them. So you have distributive property, so distribution, which we just did with that 5. So distribution is one option. And then we have FOIL. And then we have box method. Now, distribution will work for all polynomial multiplication, whether it's binomial, monomial, trinomials, it doesn't matter. Distribution will work. For me, it gets kind of big when we use bigger trinomials or and more polynomials with 5 terms and things like that. Distribution gets a little out of hand for me. FOIL only works when you multiply a binomial times a binomial, so 2 terms and 2 terms, which is the one probably you had the most practice with, the binomial times binomial in Math 1. And then box method will work for all of them. It just takes a little more time. It is really actually distribution, but it's an organizational process. Just like FOIL is actually distribution, but it's another way to organize your brain and go down the list and not miss anything. You can choose whichever way you want to do it. I focus on box because I've seen the most success. But if box does not work for you, or it aggravates you, or you don't want to take the time, use FOIL. Or if distribution works for you, just get the answer right. How you get there, you can choose any of these ways. So our first example, super simple. You could do box method, but it'd be a waste of space maybe and time in this case, because you've been doing a basic distribution like this since 8th grade. So we're going to take the first one. So 2 times x squared is going to be 2x squared. And then 2 times 3x is going to be 6x. It is in x squared and then x order. Because this was already in descending order or standard form, then your answer came out in standard form and you're done. So that's the most basic distribution you possibly can do. We have an error analysis of that to make sure we can practice those. So if you're looking at this person's work, if they distributed 4x to x, you should get 4x squared. So we're good here. And then 4x times 3 should be 12x. So they left off the x. They ended it with a constant when it shouldn't have been a constant. They threw out the x that was attached to that 4. So their mistake was in the distribution of 4x times 3. So it should be that 12x. And this is also factoring out a GCF. If you were to look at it backwards, just because this is an honors meeting, you could look at this problem and know that it has 4 in common and it should have an x in common. So that's why the 4x works on the way out. So if you worked it backwards, because sometimes problem solving backwards is easier for some people's brains. But again, whichever way works for you works for me. Let's get into the right answer and understanding what we're doing. All right, binomial times binomial. So FOIL. So first, so x, so x squared. And then outer, FOIL, so that's outer. So the outer two terms. So x times a negative 2, which would be negative 2x. I is going to be inner. So 3 times x is going to give me a positive 3x. And then last should be 3 times a negative 2, which is going to give me a negative 6. Sorry, guys, my colors aren't changing like I'd really like them to. But so that's going to be your last. So that's FOIL. Then you're going to combine your like terms in the middle. And so our answer should be x squared plus x minus 6. And you don't have to put that 1 because negative 2x plus 3x is 1x. But you know it's already there. We learned that a long time ago. But if you do, that's fine too. That would be another one of those areas where you just want to make sure you read the instructions on the problem and that you're inputting the answers the way it asks you to, especially in your error analysis stuff. All right, so that process in box form, so x plus 3, x minus 2, it's the same idea. So first would have been x times x. So we're going to go x times x and work into our box, so x squared. And then outer would be x times negative 2, so negative 2x, same as we did here. Then inner would be 3 and x, so we get 3x because 3 times x is just 3x. And then last would be 3 times negative 2, it's going to be that negative 6. So it's going to be x squared. We're going to combine like terms. If your binomials, trinomials are all in standard form, when you place them on the outside of the box, your like terms should be diagonal to each other, like touching at the points. If they happen to not be in standard form when you put them in there, or they've skipped exponents, sometimes you got to look around a little bit as the box gets bigger to find your like terms. But again, 3x minus 2x is going to give me x, or 1x. And then our last with our constant is 6. So again, it's the same math. It's an organizational difference that you would have to do. And realistically, as far as distribution, this is distribution. We distributed the x, then we distributed the 3, and then we combine like terms. So FOIL is distribution. Again, it's just a change of organization. So looking at an error analysis, so especially with a bunch of numbers and negatives and positives like this, again, I would write this off to the side and I would try to solve it myself without looking at their work necessarily. So x times x, I know is x squared. Then x times 8, I know is a positive 8x. And then negative 8 times x is going to give you a negative 8x. And then negative 8 times a positive 8 is going to give you a negative 64. Now, because I get a little impatient and I want to know right now, I would take this and I would look here. So x squared plus 8x minus 64. So apparently they did the multiplication portion perfect. And then combine our like terms, which would be these two guys in the middle. And since it's a positive and a negative of the same number, they cancel each other out. So it's x squared minus 64. So their mistake was that they treated this positive 8x like it was a negative and then combined these two like terms. So this would be their first mistake, is combining the wrong terms. So their mistake is in line 3, but they also messed up and somehow turned this negative into a positive because they magically felt the need, apparently. So their mistakes would be not combining the terms 8x and negative 8x appropriately, and then not carrying down the constant correctly would be some of your reasons if you need to write a reason to why they messed up. All right, so binomial times trinomial. So these are the ones that people get a little more messy, I guess, per se, or maybe they lose the organization, especially when they're as ugly as this, maybe, if you think it's ugly. Bigger numbers, more negatives, lots more exponents. So distribution-wise, c times a negative 9c to the 4th power is going to be a negative 9c to the 5th power. Then c times a negative 7c cubed is going to give me a negative 7c to the 4th power. And then c times negative 5c squared is going to get negative 5c to the 3rd power. Because remember, when you multiply the exponents, they add together. So there's an imaginary 1 there. So 1 and 4 is 5, 1 and 3 is 4, and 1 and 2 is 3. Then you should distribute your negative 3 times a negative 9, which is going to give you 27c to the 4th. I like to stack mine, which one of your videos should have shown you when you were adding and subtracting too, instead of just letting it go long and forever. That sort of lets me know that these two are going to be the same family. So combining like terms-wise, not doing that later, but doing it as I go. So negative 3 times a negative 7c to the 3rd power is going to give me a c to the 3rd. So negative 3 times a negative 7 gives me 21 c to the 3rd. And then negative 3 times a negative 5c squared. So negative 3 times negative 5 gives me a positive 15. And it's a 3, so there's not a c, so c squared sticks. And it's just c squared. Then at this rate, you can work straight down and combine your like terms. So negative 9c to the 5th is still the front term, because you, again, 5, 4, 3, 2 is in standard form, so descending order. Negative 7c to the 4th and positive 27 should give me a positive 20c to the 4th. Then negative 5c cubed plus 21c cubed means I'm going to take 5 away from that 21. So it's going to give me 16c cubed. And then last but not least, that 15c squared doesn't have anybody to combine with, so it just comes down as is. And then that should be your final answer in standard form, descending exponents, using distributive property for solving the multiplication of this binomial times trinomial. So bi times tri would be 2 times 3. The next one, I'll do box method. So if you, again, you can still use distributive just like we did, but box, so it's going to be 2d minus 2, because it's binomial, and then trinomial. So 4d to the 5th, 3d to the 4th, negative 2d to the 3rd. Now, this is one of the places people mess up. When you're putting it into the box setup or setting up your box method, make sure you're paying attention to your pluses and minuses. Sometimes I even just write the problem as is. So 4d plus 3d to the 4 minus 2d to the 3rd, in hopes that I keep up with all my pluses and minuses. So we're going to work our way in. And this is, again, just like distribution, just change in organization, because if I distribute my 2d, I'm going to work straight across the top here. So 2d times 4d to the 5th, so 2 times 4 is 8, and d and times d to the 5th is going to be d to the 6th power. So 2 times 3 is going to be 6, and I have d to the 4th and a d, so that's going to become d to the 5th. Negative 2 times a positive 2 is a negative 4, and it's going to be d to the 4th, because I have 1d and 3d's. So that's distributing 2 all the way through, the 2D all the way through. Now we're going to work with our negative 2. Negative 2 times 4D to the 5th is going to be a negative 8D to the 5th, because there's not a D here and there's 5 here. So negative 2 times 3D to the 4th, so negative 2 times 3 is negative 6D to the 4th. Then negative 2 times a negative 2D third, so negative 2 times negative 2 is positive 4, and D weak to the third power. Now you're going to combine your like terms and pull things out. Because this was 5, 4, 3, and this is 1 and none, that is in standard form. So again, you're going to find your like terms at diagonals. So 8D to the 6th is our first term. Then we're going to combine our D to the 5th. I'm in the whole 8 and I have 6. So it's going to be minus 2D to the 5th. And then we have D to the 4th. So we have a negative 6 and a negative 4, which is going to be a negative 10D to the 4th. And then last but not least, 4D to the 3rd. And so that's in 6, 5, 4, 3. So descending order. So that is in standard form, combining, multiplying a binomial times a trinomial using the box method instead of our distribution like we did the last one. We have about 4 more minutes. So for that, I'm going to skip up to error analysis. So again, up to you, but I would maybe write this over to the side and solve it yourself, because practicing solving it as well is helpful, again, because if you're having positive and negative drops, or you know you're losing attention to things, the more you do, the less you will do that. So we are going to 5z times z squared is 5z to the 3rd. 5z times a negative 2z is going to be a negative 10z squared, because positive 5, negative 2, and then z times z. Then positive 5z times 3 is going to be 15z. So we've distributed the 5z all the way through. Let's see if I can get my pen to change to a color red. Let's do the 7. So 7 times z squared is going to be 7z squared, which is the family member of this one. So 7z squared. And then 7 times a negative 2z is going to be a negative 14z. And then 7 times 3 is going to be 21. That means you've distributed the 5z to all 3, and you've distributed the 7 to all 3. You can compare. So 5z to the 3rd, 5z to the 3rd, perfect. Negative 10z squared, negative 10z squared, awesome. 15, 15z. So we've now found our first mistake, or at least one mistake. That should have a z attached to it, because it's not just 5 times 3. Then we have a positive z squared. We had a positive z squared. Negative 14z, we had the same. And 21, we had the same. So as far as that was concerned, their only mistake was leaving off the z for this one. So our final answer is 5z to the 3rd. Negative 10 plus 7 is going to give me a negative 3z squared. So their answer looks good so far. But 15z minus 14z, or plus a negative, is going to leave me with 1z, or just z. And then last but not least, 21. So that boo-boo in losing that z here cost them the whole back half of their answer. So their first mistake was in line 2, but it definitely played out to be a bigger mistake at the end, because it's not even remotely the right answer. So that would be your error analysis of multiplying a binomial times a trinomial.